Hi everyone, I am Ramesh from Cambridge Institute of Technology. Today's my topic is binomial probability distribution. My dear students, already you are familiar with the discrete and continuous probability distribution. In discrete probability distribution, the random variable x has finite number of values, whereas in continuous probability distribution, the random variable x has infinite number of values. Further, in discrete probability distribution, there are two types. One is binomial probability distribution. Second one is Poisson probability distribution. Now in this video, I would like to explain in detail about binomial probability distribution. First, you should know what do you mean by the binomial probability distribution. Here bi means two. That means in this distribution, you have two possible outcomes. One is success and the other one is failure. That's why this distribution we call it as binomial probability distribution. Now we should know what is the formula to find the probability of a random variable x in binomial probability distribution? That is given by p of x is equal to ncx p raised to x q raised to n minus x, where x is greater than or equal to 0. That means here x takes the value 0, 1, 2, 3, etc. up to n. Otherwise, that is equal to 0. Where n is the total number of trials, x is success, p is probability of success, q is probability of failure. The important points to be remembered in binomial probability distribution, that is, first one, p of x is greater than or equal to 0 for all x. Second one, summation over I equals 1 to n p of x is equal to 1. The third one, p plus q is equal to 1. That means in any probability distribution, probability of success plus the probability of failure is always equal to 1. Next, the mean of binomial distribution mu is equal to n times p. Variance is sigma square is equal to npq and standard deviation is sigma equals square root npq. Now let us move on to problems. Actually a proof for all these points, but in your syllabus you don't have proof. That's why just you have to remember all the standard result, because by solving problems we need all these standard results. Now let us move on to the problems. Consider one simple example. You see, in this problem, the number of telephone lines busy at an instant line is a binomial variate with a probability 0.1. If 10 lines are chosen at random, what is the probability that? First question, no line is busy. Second one, all lines are busy. Third one, at least one line is busy. Fourth one, at most two lines are busy. Now let us compute all these probabilities for the given data. First define x always. Here x denotes the total number of telephonic lines are busy at an instant of time, because here busy is the outcome. Busy is the outcome. Accordingly, you should assign this outcome for the variable x. Now by data we have here the telephonic line busy at instant is given by 0.1. That means p is equal to 0.1. Obviously q equals 1 minus p, that is 1 minus 0.1, that is equal to 0.9. Next, here we have chosen at an instant totally 10 lines at random. That means here small n is equal to 10. Now let us consider standard formula for p of x in binomial probability distribution, that is equal to p of x equals ncx, p raised to x, q raised to n minus x. In this formula, let us substitute for n, p and q. We get p of x in terms of x. Call it as equation 1. Now with the help of this equation, easily we can compute all the required probabilities just by changing the value of x. Now consider first one. The probability of getting no line is busy. That means here for this problem, you have to consider, you have to find p at x equals 0. No lines is busy means x is 0. Here x denote total number of lines are busy. No line is busy means here x is 0. Now let us compute p at x equals 0 with the help of this equation. In this equation, if you replace x by 0, we get this 10c0, 0.1 to the power 0, 0.9 to the power 10 minus 0. Now let us simplify this with the help of calculator. We get 0.3486. This is the answer for the first question. Next, consider second one. The probability of getting all lines are busy. Here x denote the total number of lines are busy. All lines are busy means here what is x? X is equal to 10. That means for this problem we need to compute p at x equals 10. That means in the above formula just replace x by 10 and simplify. That is 10c10 0.1 to the power 10 into 0.9 to the power 10 minus 10. If you simplify this, we get 0.1 to the power 10. That is the answer for the second question. Next, the third question is the probability of getting at least one line is busy. At least means greater than or equal. Here we need to find the probability of getting at least one line, means here we need to compute p for x is greater than or equal to 1. Here in this problem, x takes the value from x equals 1 to x equals 0 to x equals 10. Here we need to find p for x is greater than or equal to 1, means we need to find p of 1 plus p of 2 plus p of 3 etc. p of 10. Instead of compute too many probabilities, we can find 1 minus p for x is strictly less than 1 because sigma p of x is equal to 1. Now that is equal to 1 minus, here p of x is less than means here only one value, that is p at x equals 0. Now let us simplify this. P of 0. Find p of 0 by using the same formula. In that formula, if you replace x by 0 and simplify, we get p of 0, that is 0.3486. If you simplify this, we get p for x is greater than or equal to 1 is equal to 0.6514. That is the answer for the third question. That is the probability of getting at least one line is busy at an instant of time. Fourth one. Here we need to find the probability of getting at most two lines are busy. At most means less than or equal. Here we need to compute p for x is less than or equal to 2. Here x will take three values. One is x equals 0, x equals 1, x equals 2. So now let us compute p at x equals 0 by using same formula, p at x equals 1 by using same formula, p at x equals 2. With the same formula, substitute all and simplify. We get for p at x equals 0 we get 0.3486, p at x equals 0 we get 0.3874, p at x equals 2 we get 0.1937. By adding these three, we get p for x is less than or equal to 2 is equal to 0.9219. So that is the answer for the fourth questions. Is it clear? I hope you understand this. Thank you.